Good evening, everyone. I am Dr. Satyabrata, MDTM clinical pharmacologist, and today I am going to discuss on confidence interval. So, studies are done on sample. You all know that. And a study population is a small sample of the entire population with that disease. And study sample is used to estimate the effect of the intervention on the larger population with that disease. And there is uncertainty in using this sample to estimate for the larger population. So this uncertainty can be quantified with p-values and confidence intervals. So steps to be taken in a study. First, we have to take two groups, group A as study, group B as control. Then calculate mean effect, that is difference in the outcome, variance in mean effect, and then state a null hypothesis. Mean effect is zero. Null hypothesis is the type of hypothesis used in statistics that proposes that there is no statistical significance exists in a set of given observations. Then we have to calculate confidence interval and p-value. For most of the scientific calculations, CI, that is confidence interval, taken as 95%. For example, group A receive intervention and losses 10 kg of weight. Group B receive placebo oblique no intervention, losses 4 kg of weight. So main effect is average weight loss of 7 kg. The true effect of the intervention is likely not exactly 7 kg but has uncertainty with it. And this can be represented based by a range, and the CI confidence interval address this range. So what is confidence? Research is done on sample and results are extrapolated to population, and the degree of surety with which we can generalize the result is called confidence, and it is known as inferential statistics. And to achieve 100% confidence, we have to study entire population. Coming to definition of 95% CI confidence interval, the interval computed from sample data which, when the study is repeated multiple times, 95% of data from population will fall in this interval. Then coming to ST, that is standard deviation, most commonly used measure of dispersion, is equal to square root of variance. So calculation of variance, distance of each data point from the mean is taken, then squared, summed, and average is taken. So population variance sigma square is equal to summation xi minus mu square divided by n. Sigma square is equal to population variance, xi is equal to term in data set summation sum, mu is population mean, and n is equal to population size. So from the ST standard deviation, we may determine if the data has a normal distribution or other mathematical relationship. So CI confidence interval taken as 95% is calculated by CI confidence interval is equal to mean plus minus 2 AC. AC is standard error. AC standard error is equal to ST, that is standard deviation, divided by root over n. N is equal to number of sample. So here AC is the for population standard error and ST standard deviation is for sample. So this image shows the mean, 1 standard error, 2 standard deviation, 3 standard deviation, and that is 68% confidence interval and 95% confidence interval and 99.7% confidence interval is shown in this figure. For example, we have 6 sample data. So x1 is equal to 1, x2 is equal to 2, x3 is equal to 3, x4 is equal to 4, x5 is equal to 9, and x6 is equal to 10. Concept: count, value 6, symbol or formula n. Sum is 28. Summation xi is equal to x1 plus x2 plus xn. So here the summation is 1 plus 2 plus 3 plus 3 plus 9 plus 10. So minimum is 1, maximum is 10, range is 9, maximum to minimum is 10 to 1, and median here is 3, mode is 3, mean is equal to 4.667, mu is equal to summation xi by n, 28 by 6, variance is equal to 12.222, sigma square is equal to x1 minus mu square plus xn minus mu square divided by n, that is 73.33 by 6, that equal to 12.223, and standard deviation is 3.496. Sigma is equal to variance root over is equal to sigma square root over equal to 12.222 root over, that is 3.496. So CI, confidence interval, is equal to mean plus minus 2 AC, that is standard error, or and standard error AC is equal to ST, standard deviation divided by root over small n. So confidence interval CI is equal to 4.666, that is mean plus minus 2 into standard deviation is here 3.496 divided by root over 6 root over n, that is 6 root over 6 is equal to 4.66 plus minus 2.86 is equal to 1.8 to 7.52 range. So lower confidence limit and upper confidence limit. Lower confidence limit is 1.8 to upper confidence limit is 7.52. So that is the confidence interval. For example, how to calculate CI, confidence interval of systolic blood pressure for a population. Mean is equal to 120 mm of Hg. AC, standard error, is equal to 10 mm Hg. So confidence interval is a mean plus minus 2 AC. Confidence interval is found to be 95, that is 95% is equal to 120 plus minus 2 into 10 is equal to 100 to 140. So lower confidence interval limit, confidence limit is 100 and upper confidence limit is 140. So systolic blood pressure is between 100 to 140, that is confidence interval, 95% confidence interval. So confidence interval influenced by two factors: sample size. More people we study, the narrower is the confidence interval CI, and spread of data, that is more variable the data, the higher is the ST, standard deviation, the wider is the CI, confidence interval. Then coming to interpretation of confidence. A, B, C. So A, if CI, confidence interval, includes null value, it is statistically insignificant. Relative risk divided odds ratio RR by OR is equal to 1. No association of a factor with the disease. B, more the distance of point estimate from null value, more is the significance. If RR is equal to 1.4, RR is equal to 3.4, more significance. And C is smaller the CI, confidence interval, more is the significance. So this is the image showing the risk ratio at 1.0 and the risk ratio from 0 to 10, and there is shown rejected significant on the left side. On the right side it is not rejected, compatible with the null. Then coming to Z score, position of an individual value with respect to mean in terms of Z score. Z score indicates how many STs, standard deviations, an observation is above or below the mean of the normal distribution. Formula for converting any score to a Z score. Z is equal to x minus mu divided by sigma. Mu is mean, sigma is standard deviation. So confidence level will be, the confidence level and confidence interval are not the same. Here the confidence level 90%, Z score is 1.645. For confidence level 95%, Z score is 1.960. Confidence level 98%, Z score is 2.326, and confidence level 99%, Z score is 2.576. So applying the normal distribution Z scores, a positive Z score indicates the value lies above the mean, and a negative Z score indicates the value lies below the mean. So you can see this picture and you can learn more about this Z score and confidence interval from different articles and books. So then coming to testing of hypothesis, we have two hypotheses. One is null hypothesis H0, means no difference between new drug and placebo. Alternate hypothesis HA, there is difference between drug and placebo. So what is type 1 error and type 2 error? Type 1 error is also known as alpha error, and type 2 error is also known as beta error. Type 1 error, alpha error, that is false positive differences. And in case of type 2 error, beta error, that is false negative differences. And type 1 error, alpha error, there is no difference between drug and placebo, but the study is showing a difference by chance. In case of type 2 error, beta error, difference was present, but the study could not detect. In case of type 1 error, alpha error, type 1 error is fixed at 5%, known as alpha, that is level of significance. Type 2 error, beta error, due to less sample size. Type 1 error, alpha error, confidence level is equal to 1 minus alpha. Type 2 error, beta error, power, ability of a study to find a significant difference if present. So power is equal to 1 minus beta. Then type 1 error, alpha error, p value tells the probability of committing type 1 error. Type 2 error, beta error, power, alpha, sample size. Power proportional to sample size, that is type 2 error, beta error. So this is the diagram showing bell-shaped curve, showing the alpha error, beta error, and 1 minus alpha, 1 minus beta, H0 mu is equal to 6.0, HA mu is less than 6.0, and statistical power. And from to the left it is reject the null hypothesis, and to right it is failed to reject null hypothesis. And in the right side there will be both sides alpha by 2, 2.5%, and standard deviations are there. One standard, two standard, plus s, one standard plus 2s, two standard plus 3s, three standard deviation, minus s standard deviation, one standard, minus 2s, minus 2 standard, minus 3s, minus 3 standard deviation. And from plus s to minus s, it is 68% confidence level interval, and from plus 2s to minus 2s, it is 95%, and from plus 3s to minus 3s, it is 99.7% of confidence interval. So when confidence level is set at 95%, alpha is equal to 5%, p value indicates evidence against the null hypothesis calculated in a software, for example Excel SPSS. If p value comes less than 5%, 0.05, then study is accepted and null hypothesis is rejected, that is drug with more than placebo. If p value comes more than 5%, that is 0.05, study is rejected and null hypothesis is accepted. So these are image showing p value. So you can go through different books, articles on confidence interval to learn more about this confidence interval. So that's all for today. Please subscribe and like, subscribe my channels, like my videos, and watch the videos completely so that you can gain a lots of knowledge about different topics. So so please like, share, and subscribe, and comment on these videos, uh, and ask questions so that we can discuss on these topics properly and perfectly. So that's all for today. Thank you very much. Jai Jagannath.